All right, this is 9.3 properties of logarithms. We're halfway through our logarithms unit. So what we're going to do first is we're going to go over the homework. So if you have that, pause this, pull that out. So here was 1 through 4. So your job was to rewrite each one as a logarithmic form. So remember, the point of a log is to figure out what the exponent was. Like, that's its job. So this 3 becomes the base. This answer becomes the input. So we say, hey, if you're multiplying 3 over and over and over again, and you get 243, what was the exponent? So remember, that's the job of a logarithm. So as you can see, it's asking that question right here. The base was 3, the answer was 243. What was the exponent? Oh yeah, the exponent was 5. So look over those, see how you did. And then just very similarly on 5 through 8, now you're just basically translating that back to exponential form. So the base was 5, the exponent was 3, and it created 125. All right, and then same idea here. In the homework, you just said 3 to what exponent gives me 27. That's what that's asking. It's saying your base was 3, you got 27. How many times did you multiply 3 to get 27? And that answer was 3 times, obviously. Okay, similarly here, the base was 2. We don't know what the exponent was, but we got 32. Okay, the exponent was 5. And then take a look at those. And then we graphed these. And if you remember, there's something really cool going on. You always have that point at 1, 0, and 2, 1 because of the exponent rules with the log. And the 2 is always the b. Okay? But then it got shifted left 1, so it shifted our asymptote, it shifted our 2 points, and then we got that. And then here's 2 more for you to just see there what's going on. And take a look at the domain range. So you can see the original points, right, is 1, 0, and then b1, so 4, 1. All right, so we have 1, 0, then we have 6, 1, because our b was 6, as you can see here, and that was your homework. All right, and then this down here was to be put into the calculator. And yeah, if you have any questions on those, let me know. All right, so back to the notes. What I want you to do is pause this and get out. Actually, don't pause it yet. Sorry, I wanted to go over some exponent rules real quick first. So have these up here, exponent rules. Okay, so a few things about exponent rules. If we have x to the a times x to the b, if you remember, it was x to the a plus b. So you can give yourself an example of that. 2 squared times 2 to the third just means that we're multiplying 2 1, 2, 3, 4, 5 times. We could just add those. Okay? So the multiplication meant we were adding our exponents. Other thing, x to the a over x to the b, if they were dividing instead of multiplying. So if we have, for example, oh, sorry, let me explain that. That'll be a minus b, if you remember. So if we have 2 squared divided by 2 to the cube, so 2 squared is 2 times 2, 2 cubes 2 times 2 times 2. So those 2's cancel out, and that's basically why we're subtracting, and we're going to get 1 over 2. Now if we just did it straight up, right, we'd have 2 to the 2 minus 3, which is 2 to the negative 1. Remember that negative exponent actually means we're dividing by 2. Okay. The next exponent rule that we learn is x to the a to the b. That's when you multiply a times b. So an example of that, if we have 2 squared, and then we're going to multiply that 3 times, so we have an exponent of 3. That'll be 2 squared times 2 squared times 2 squared, which is 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6. Okay, and using that rule, we can just do 2 to the 6th. All right, so those are the exponent rules that we're going to talk about. All right, so this time really, what I want you to do is pull out a calculator, and you can use any calculator because this is log base 10. I'm not going to change the base just so that it's easy to put into your calculator and go through. So go ahead right now, pause this. What you'll do is you'll put all these into your calculator and see what you get. Same thing there, and answer those questions to the side. So again, pause this, go ahead and do that. All right, welcome back. So just real quick, you should have got 1.0792 here, 1.0792. So why were those the same? Kind of think about that. All right, and then the next one, you got 0.9542, 0.9542. Why are those the same, right? What's going on here? And then the next one, you got 1.2553, 1.2553. Okay, so number 2 says, using the patterns you see in the table, complete the equation below. And it looks like log x times y gives us that answer. Now I want you to kind of think about this, right? So 3 times 4 obviously gives us 12, 3 times 3 gives us 9, 6 times 3 gives us 18. Okay, so yeah, it looks like this rule is very much true. And you proved it with your calculator, right? So the question is, why? That's the question, why? And I want you to reference this rule right here. This one, it's kind of ugly. I mean, I'm getting this really messy. But this rule right here, x to the a times x to the b equals x to the a plus b. Now remember, the answer to a log is an exponent. Okay? The answer to a log is an exponent. So this is really saying 10, right? It's base 10. 10 to what gives me 3? And that what is the answer to the log? What was the exponent? So we have an exponent plus an exponent. And we know when we're working with exponents, exponent plus exponent, that goes to multiplication, okay? Kind of cool. All right, number 3. How could we find the value of log 30 if the 3 button was missing on our calculator? So I want you to think about undoing this rule up here, right? So instead of log 30, are there 2 numbers we could multiply to create 30 that don't involve the number 3? Well, we can't do 3 times 10, right? We can't do 1 times 30 because the 3 button's missing. Well, what if we did 2 times 15? Okay? I mean, we could plug that into our calculator, but we could also do log of 15 plus log of 2. So we could either put this in or this in, and we'd get the exact same thing, which would be the exact same thing as log 30, right? All right, so this one, number 4, hopefully you tried this one, and you got 0.06990, 0.6990. Interesting, right? Now, why is that happening? Well, take a look right here at this exponent rule and kind of think about it. Here we have 0.8451, 0.8451. Now look at this one, kind of interesting. Negative 0.3010, negative 0.3010. So first off, what's the relationship here? How does 10 and 2 get back to 5? The only way I can think of it is 10 divided by 2. Right? Okay, how does 28 and 4 get us back to log 7? That's the only thing I can think of. Alright? And then how do we get to 1/2? That'll be log 3 over 6. So if some reason we need to combine these or to make them bigger no matter what, right? The relationship is if you're subtracting your logs, it'll be the same as log of x over y. So similar idea, what if we wanted to create log 30, but we didn't have that button, right? We didn't have that 3 button. 3 was gone, but we still need to find log of 30. Well, let's think about it. We can do log of x minus log y will equal log of x divided by y. So if we could think of a way, and I'm going to erase these, but know that the top will be the first one, the bottom will be the second one. If we could think of a way to get 30 by dividing, I mean, and there's lots of ideas, but 60 divided by 2 could work. So then we'd have 60 and 2 right there. All right, a student noticed that log of 1/2 was the same as negative log 2. How is that possible? So log of 1/2 was the exact same as negative log 2. All right, so if we use that rule that we have up in number 5, we know that log of x over y equals log of x minus log of y. So let's plug in those numbers. Log of 1/2 equals log 1 minus log 2. So we're really close, but the question is, where did log 1 go, right? So if we think about it, 10 to what gives us 1? Or put log 1 in your calculator. You're going to get 0, okay? So if the exponent's 0, the base will always go to 1, which is what log 1 is saying. So that goes to 0. So we have log of 1/2 equals 0 minus log 2, which is negative log 2. Except I have an extra L there. Negative log 2. Great. All right, flip that page. Saul was practicing evaluating logarithms on his calculator. After he had finished all the calculations, he was startled at the results. He was sure that his calculator was broken. What do you think? So why was he getting the same thing over and over and over? What's going on, right? Weird. So through what we just worked on, this one shouldn't be too crazy, right? So 5 times 5 is 25. We just talked about that rule, right? And this one shouldn't be too crazy, right? Because log of 5 times 5 should be the same as log of 5 squared. Okay. So basically an exponent raised to an exponent, if you think of that rule, so like x to the a to the b, if you remember, was x to the a times b. So let's take a look at that there. How are these relating? Okay, kind of think about that. And it has a lot to do with this rule right here, right? So if we have an exponent raised to a power, it is the same as multiplying, okay? All right, and then this one over here, we have 3. So that shouldn't be too much of a surprise, nor this one. Okay. So kind of think about that. Okay. All right. So a few notes on this real quick. Log 5 squared equals log of 25. Okay. Log 4 to the third equals log 64. But 64 could also be written as log 2 to the 6, since these all are log 64. Okay? Now, where's this 625 coming from? Well, notice if we move this up here, we could have log 625 to the 1/2 should also be 1.398. Check that in your calculator, but that's the square root of 625, and it's kind of cool fact there. All right, write two more logs that are equivalent to 1.806. So we're starting with this guy here, right? So if I have two of them, I could write 2 log to the 4th plus log to the 4th, which would be log 4 squared plus log 4. All right. Another thing I could do, if you kind of think about it, what if I break this one up, right? So what if I have 3 log 2 plus 3 log 2? Put that in your calculator, right? Log 2 to the 3rd plus log 2 to the 3rd, because I'm noticing 2 to the 3rd times 2 to the 3rd is 2 to the 6th. So kind of using that rule to break it up. All right, so let's put this all together. So if you have a log base x plus log base y, it'll equal log base x times y. If you have log base x minus log base y, that's a subtract sign. Let's clean that up a little bit. It's going to equal log base x over y. And if we have log with an a constant in front of it, it'll give us log base x to the a. Now mathematicians call going from this column to this column condensing. And they call going from this column to this column expanding. So if you see that wordage, that's what they're talking about. All right, let's check your understanding, make sure you're feeling good on this. We're going to expand each logarithmic expression. So because these are held together by multiplication, remember what we can do is add them. Okay, so that's expanded. If they're held together by division, you can then subtract them. Now notice the first part is held together by multiplication, so I can also separate those by addition. Okay. Number 2. Now we're going to condense them. So log 3 x times x, which is log base 3x squared, or 2 log 3x, either one. But this is probably the most condensed. All right, this one here, we're going to have ln 5 squared minus ln of 4, which, because it's subtraction, it can be 5 squared over 4, which is 25 over 4. Okay, which of the following is not equivalent? So we could put these all into our calculator, but that's going to give us log 4 squared, which is log 16. This one's going to give us log of 8 times 2, which is also log 16. This is going to give us log 64 divided by 4, which is also log 16. And then this one down here is going to give us log 256 to the 1/2, which is log square root of 256, which is log 16. Okay, so it looks like E, they're all equivalent. Okay, so Chandler wants to rewrite log 2 32a cubed and then simplify. He wants to rewrite it and then simplify. His work is shown below. Okay, so the first thing that he did was notice 32 times a cubed could be expanded using addition. And then 2 to the what gives us 32? Well, the answer is 5, right? And then this other part stayed the same. Then he moved this 3 to the front. Then he said 5 plus 3. But notice these are not like terms, right? You have 3 logs, and we have 5, just 5's a constant. So he made his first mistake in step 4. You can't combine unless they're like terms. And they aren't. So you can't do it. Right, that's it. That's what you got to do. Good luck. Let me know if you need any help on the quiz or the homework or anything.